Welcome! Today we'll evaluate the infinite series sum from n equals 2 to infinity of 1 over n times n minus 1. To solve this, we'll use partial fraction decomposition. The denominator can be factored as n times n minus 1, so we can split our fraction into two simpler fractions, a over n minus 1 plus b over n, where a and b are constants we need to find. To find a and b, we'll multiply both sides by n times n minus 1. This gives us 1 equals a times n plus b times n minus 1. Distributing the right side, we get 1 equals n plus bn minus b. Collecting like terms, we have 1 equals n times a plus b minus b. Since this equation must be true for all values of n, the coefficients of n must be equal on both sides, and the constants must be equal. This gives us a system of equations. A plus b equals 0 and negative b equals 1. Solving this system, from the second equation, b equals negative 1. Substituting this into the first equation, a plus negative 1 equals 0, so a equals 1. Therefore, our partial fraction decomposition is 1 over n times n minus 1 equals 1 over n minus 1 over n. Now we can write our series as the sum from n equals 2 to infinity of 1 over n minus 1 over n. This is a telescoping series. Let's look at the first few terms. When n equals 2, 1 over 1 minus 1 over 2. When n equals 3, 1 over 2 minus 1 over 3 when n equals 4. 1 over 3 minus 1 over 4, and so on. Notice how terms cancel out. The negative 1/2 from the first term cancels with the positive 1/2 from the second term. The negative 1/3 from the second term cancels with the positive 1/3 from the third term, and so on. After all the cancellation, we're left with just the first term of 1 and the negative limit as n approaches infinity of 1 over n. Since 1 over infinity equals 0, our final answer is 1. And that's how we evaluate this infinite series using partial fraction decomposition and recognizing a telescoping series. Thanks for watching.